first thing we did was write an equation using these two equations here. You're going to want to memorize those. There is one. Did y'all see your problem on your homework where you needed the one from your calculus helper? Does everyone see that one? No, there's one on the move. So you will need to kind of, both of these are on Earth, obviously, because that's the acceleration due to gravity.
Oh Lord, I'm just going to figure out something else. I don't want to forget. I want to have it forget.
So, the actual gravity equation that works anywhere is 1/2 times the gravity constant times c squared, which is the one on your calculus helper. It's more general. The gravity constant in feet on Earth is -32 feet per second squared, and the gravity constant on the moon, in meters on the Earth, is -9.8 meters per second squared. And so that's where these come from. Those of you physics people will probably appreciate the derivative of this twice. To get acceleration, I would get -9.8 meters per second squared as the acceleration due to gravity. Which makes sense, right? Well, so we wrote a function. This was in meters, -4.9 t squared plus 180. We didn't know the initial height, so we went ahead and just called it 0. And so we called this kind of our origin. Parts 1, 2, and 3 were all algebra. They actually have nothing to do with calculus, but the things the calculus exam will expect you to be able to do. And then part 3 was, when does the ball hit the ground? Is that right? Or the book? When does the book hit the ground? And what did we get?
8.08.
Say that again.
No, that's level.
8.08. And to that, we said that original equal to -160. We use the calculator to do that. What often will happen is they will ask you number 4 without asking you number 3. But you have to do number 3 to do number 4. Does everyone agree? Yeah. Speed of the opposite when it hits the ground. How am I going to find speed? I'm going to find the velocity, which is -9.8 t plus 20. And then I'm going to plug in 8.109. I would hold more decimal places than that while I plug it in. Wait around until you're done with the problem. Does everyone know what I mean by that? Keep going, just 3. If you leave your X sitting on that intersection that you found, when you type X at your home screen, it'll pull that number up. Did y'all know that? Yeah. So if you find an intersection in your calculator, and then go to your home screen and type X, it'll pull the X from the intersection. So left or right on your graphing screen. So if you want it exact, it'll pull that for you. So I want to do the absolute value of B of 8.109. Why absolute value? Speed. Speed's not negative. Velocity is negative. If it goes backwards, but speed is not negative. We should talk about that after you watch the video. You'll miss anything. Getting to see it, but you can't see it long. Got it. What is it?
Oh no.
What is this? Meters per second. When does the book reach its maximum height? Now, of course, I know I can do that without calculus by finding the maximum value, but how would I do it with calculus? First derivative, which is velocity, equals 0. What is 20 divided by 9.8?
that be kind of like a sign chart thing? Or?
Yes. Now, good question. Why did I not do a sign chart? I got the critical point, and then I just stopped. Why was I okay with just stopping and knowing that was the maximum? I do the graph. It's parabola, so I know that one critical point is going to be where the maximum happens. But you're right, if it were anything other than a quadratic, you would need to go ahead and do a sign chart to make sure it was a maximum, not minimum. Good question.
So this one doesn't go with what we just did?
It's still motion, but it says the accompanying figure shows the velocity of a particle. What's the first thing we always do when we have a problem that's like a graph? Find out what do we have here? So we have a velocity graph, which is like being given f prime. Everyone agree? This is the velocity of the function. So this is the velocity of our particle. I have some questions. Go ahead and draw that picture for me so that when I am down here, you can't see it. So I answer some questions. Part A actually asks a lot of questions. A lot packed into part A, so I'm going to do that. Part A asks me, when does the particle move forwards? When does the particle move backwards? When does it speed up? And when does it slow down? Remember, this is velocity. So what do we look for when a particle is moving forwards or backwards? Whether the velocity is positive or negative. Well, this is the velocity graph, right? So I'm looking, when is it above the x-axis and when is it below the x-axis, when is it positive and when is it negative. So it's moving forward from 0 to 1 and 5 to 7. And it's moving backwards from 1 to 5. Remember, speed's tricky. Two options. I haven't drawn a sign chart. I could, couldn't I? I could draw a sign chart for velocity, and I could draw a sign chart for acceleration. I could compare the two. That's what we would have done yesterday. However, today gives us a graph. So remember the other way I showed you how to do speeding up and slowing down? It might not be bad to pick up the other options. I'm going to show you both ways you can work this problem. One of the ways is to quickly sketch a speed graph instead of a velocity graph. And what is a speed graph in comparison to a velocity graph? What? Okay, it's almost exactly the same. Almost. Except. Right. It's absolute value, right? Is it speed? Absolute value of velocity. So anything that's negative would become positive. Now the rest is the same. Like the only part that moves is the bottom because we become positive. So that graph, except with the dark blue instead of the light blue on the bottom, is the graph of speed. So when am I speeding up? Good. 1 to 2, 5 to 6. How did he get that? But the speed is increasing. Everyone agree? If you're speeding up, the speed is increasing. So from 1 to 2 and from 5 to 6. And because we have a graph, that is not too terrible to do. Now yesterday, we felt like that option was terrible. Why? We didn't have a graph, right? to 1 and let's see, where is that? 3 to 5.
Why?
Because this is going down.
That's not good.
Well, I drew that picture. Oh.
If it looks like it's from 4 to 5 on ours, we just do that. We'll really mess everything up.
That's fine. Just make sure that it looks like that down here also. You know,
like it, yeah.
That's fine. So from 0 to 1, 3 to 5, and 6 to 7.
How do you know it's speeding up again?
The speed graph is increasing. Or the speed graph is increasing. Now, again, that's a tough thought process. What's the other option? Good. We're going to look at a sign chart comparison. This would be new to you. This is good for you to know because if you're given an equation instead of a graph, it's more useful. Couldn't I sketch the velocity sign chart? 1, 5, 7. Velocity is positive, negative, positive, and then you might mental note it's 0 out there. Agree? Could I make an acceleration sign chart? Acceleration is the slope of velocity, agree? So until 2, it's negative. From 2 to 4, 2 to 3, it's 0. From 3 to 6, it's positive. And from 6 to 7, it's negative. And then from 7 on, acceleration would also be 0. Everyone see how we got that? What do we look at when we're doing speeding up and slowing down? If the velocity acceleration have the same sign, we're speeding up. If velocity acceleration have opposite sign, we're slowing down. Right? So we can look at that really quick. Again, the place this is really handy is if you already have sign charts made, you don't have graphs. So from 0 to 1, opposite signs, slowing down. Is that what we got? From 1 to 2, both negative, speeding up. 2 to 3 we completely leave off because if the velocity or acceleration is 0, that means we are neither speeding up or slowing down. From 3 to 5, opposite signs, slowing down. From 5 to 6, same sign, speeding up. From 6 to 7, opposite signs, slowing down. After that, we got zeros, so either speeding up or slowing down. So that's a good look at both options for how to do speeding up, slowing down. Part B. When is the particle's acceleration positive, negative, or 0? I think I just answered that. Would you agree? I just drew an acceleration sign chart. It is the slope of velocity. So we are positive from 3 to 6. Negative from 0 to 2 and 6 to 7. And 0 from 2 to 3 and from 7 on. Just stop somewhere. 7 on. Did I have to draw a sign chart to get that answer? No, I drew one because of something else I was doing, but remember I'm just looking at just one, but it's negative and 0. When does the particle move at its greatest speed? It might be nice if you already had that speed graph drawn, right? That was quite handy. I erased it. I might want to put it back. Now, I can see an argument on this one because the answers. Which one looks taller? That one or that? This. They look about the same, don't they? We'll make one taller, but on a real problem that you had to do this, hopefully they would make it sure one was clearly, labeled the axes. It would be easy. What we really want to know is which one's the farthest away from the x-axis velocity, right? And so it looks like from 2 to 3 based on the way I drew the picture. I could see an argument of you saying it equals 0. I take the answers I have to. There's no labeling. Yeah, other than that, I can't. I think they are completely the same because that's a line. Slope the same on both sides. We're going the same distance. So I would say they are exactly the same. Right? So at t equals 0 and from 2 to 3. When does the particle stand still for more than just an instant? What would be 0 if I'm standing still? Velocity. When is the velocity 0 for more than just an instant? 7 to 9. Not 2 to 3. What's 0 from 2 to 3? Acceleration. I am going backwards at a constant speed. So the only time is from 7 to 9. Any questions about that? Hey, you already had your homework. You don't have a ton of time left, but I'm sure. Monday is a work day on motion or our test directions. Use it wisely. Tuesday, we're doing our activity. Wednesday, we are mastery. Keep those dates in mind. Oh, pass that homework out. That'd be great. Math. Yes, 5 bonus points if you get the mastery exam correct on the first try. Don't forget to add the first try. Don't forget to add the 3 inverse trig functions to your mastery exam. Those are which ones I'm talking about. Sine inverse, cosine inverse, tangent inverse, and inverse.